Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 1 times of n plus 3 times of n minus 5 times of n minus 7 is equals to 192. Today I will solve this problem for a unique method, and here I can use a nice technique to solve this problem. So here you remember, first I can explain this technique, and you know that if you have some factors in this form, x plus a times of x plus b times of x plus c times of x plus d is equals to some k, then here you remember one thing is that you will arrange all the factors in this form if it can hold this condition. If you can add a plus b, then it is equals to the sum of c plus d. If this condition is hold, then you can arrange all the factors in this order. So now first we will just reorder these factors, and now we can check this condition. So here if you can see that we have 1 plus 3, and 1 plus 3 is 4, and minus 5 minus 7 is minus 12. So it means that these factors cannot be arranged in this form. So if you can add 1 minus 5, then it will becomes minus 4, and when you add 3 minus 7, then it will becomes minus 4. So you can rearrange these factors in this form: n plus 1 times of n minus 5 into n plus 3 times of n minus 7, and this whole is equals to 192. And now you can multiply the first two factors and the last two factors. So now first we multiply these two factors and these two factors. So when you multiply these two factors, then you will get here n square minus 5n plus n minus 5 into, now we multiply these two factors and you will get here n square minus 7n plus 3n minus 21 is equals to 192. So now we multiply these two factors here. So now we can simplify the terms, and you will get here n squared minus 5n plus n is 4n minus 5 into, here you get n square minus 7 plus 3 is 4n minus 21 is equals to 192. And now you can see here this part of both of the factors are same. So now we can put this part is equals to y. So here when you can take y is equals to n square minus 4n, so these two factors will becomes in the form of y minus 5 times of y minus 21 is equals to 192. So now we multiply again these two factors, and here you see that we will get y squared minus 21y and minus 5y and plus 105. So you get here 5 times of 21 is 105, and we move this 192 in the left hand side, so it will becomes minus 192, and this whole factor is equals to 0. Now we will rearrange these terms, and you can get here y squared minus 26y and minus 105 minus 192 is equals to minus 87, and this whole equation is equals to 0. So now we can make the factors of these this quadratic equation. So here you see that we need any two numbers whose product is minus 87 and whose sum is minus 26, so that the factor of this equation are y squared and minus 29 and plus 3 and minus 29y and plus 3y minus 87 is equals to 0. So when you can subtract minus 29 by 3, you will get here minus 26, and minus 29 times of 3 is equals to minus 87. So here we take common y from the first two terms, and you will get here y times of y minus 29, plus here you take common 3 and you will get here y minus 29, and this whole factor is equals to 0. So now in the next step we will take common y minus 29 from both of the terms, and you will get here y minus 29 times of y plus 3 is equals to 0. So here we have two cases. The first case is we take y minus 29 is equals to 0, and the other case is we take y plus 3 is equals to 0. So in this case you will get the value of y, or now we can back substitute the value of y. In the start of the question we will take here, so this is here you see that we take the value of y is n square minus 4n. So now we can back substitute this value, and you will get here n square minus 4 times of n minus 29 is equal to 0, and the second factor is n square minus 4 times of n plus 3 is equal to 0. So now we can solve these two cases here. So now if you can focus on this case, then we will see that here we can apply the nice quadratic formula in order to solve this case. So here you have a is equals to 1, b is equals to minus 4, and c is equals to minus 29, and the quadratic formula is n is equals to minus b plus minus b square minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c here, and you see that when you can put here the value of b, so you get plus 4 plus minus 16 plus 116 and its whole square root over 2. I can just put the values of a and c and simplify the term, then you will get its output in this form. And after simplification of these all factors, you will get here n is equals to 4 plus minus 2 times of a square root of 33 over 2. And when you can separate these two factors, then you finally you will get here n is equals to 2 plus minus square root of 33. So these are the first two real factors of the given equation. So now in order to find the other factors, we will solve this case here. So here we need to make the factors of this quadratic equation, so we can easily find the factors of this one. So here you have n squared minus 3n minus n plus 3 is equal to 0. So these are the factors of this equation, and here we take common n and you get here n times of n minus 3. Here we take common minus 1 and you get n minus 3, and this whole is equals to 0. So here we get n minus 3 common, and n minus 1 is equal to 0. So here we have two cases, n minus 3 0 and n minus 1 0. So finally we have two values of n, so these are 1 and 3. So finally we have the four roots of this problem. So these two roots are real and these are also real. So these are the four roots or four solutions of the given problem, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.